So I just found something odd trying to restart the stream. It does, if the stream window in Studio is open, even though I ended the stream, or say I started one and I'm already streaming, like OBS is already sending it, it will never actually start the stream. It'll say that it's there, but it won't start. So you have to stop the stream, reload the Studio screen without sending anything to YouTube, and when it's ready, then start sending, and it will automatically start. Otherwise, there seems to be no way to go live. Don't know. Very confusing, but at least I figured it out. Let's post that link, and away we go. All right. Well, we left off with, let's find the right part, this one here. This piece is what we're working on. Right at the end there, I had to fix something I had put in the wrong direction, but otherwise, that's what we're working on. We were adding some chamfers, kind of dressing some things up. There's a few more holes. Well, we have to add all the holes and offset still. Let's see here. We can't change the screw size because that goes into an existing hole. That's fine. And the threaded hole, I need to leave room for adding threads because the other side might already exist and you may want to use that to thread it in. But if you don't, that's okay. It looks like there's a pin in here. So what I'm looking at here is this screw holds it onto the piece of equipment. That one has to be the same size because the thing it's screwing into is the same. This is a threaded hole because the top piece, this thing, let's see if I get the right side. When these two go together, this can screw in. So that's a fixed thing, and I need to make the hole so that those threads can cut their own thread in there. But this is all you really need, because this is just to keep it from sliding past each other. It doesn't have to be screwed together. That's just a convenience. So I think this will work just fine. Where did we leave off at? There's a couple more decorative chamfers that aren't important because they're small, and the printer will smooth that out. Overall, it looks like we're in good shape. This hole needs to go in there. I need to actually put that hole there. Otherwise, does that look the same? How about there's something? Oh. That's interesting. 13. No, why is that interesting? That's 10. Why does that look like it's offset more than it should be? I don't know. Anyways, we also have to put a recess here for the screw to go in. And that hole is centered there. It's about 7, but let's check my screwdriver. So the screwdriver I tend to use is this one, and it's a fairly common size. And it needs 6.5, about 7. So it would definitely fit in a 7, but just barely. If I can get an 8 in there, I will. So let's try with an 8 first and see what happens. down. That's looking a bit chunky. Center it up. There we go. Yeah, that would just blow out that edge. At least right there it would. So 7.5 at best. That doesn't look quite right. Yeah, that's centered. I think it's just the angle I'm looking at. What is going on? Ah. Nope. That's centered. Okay. Let's shrink this to 7, I guess. Using the same trick from last time, taking half off each side. I need to make this alright. Let's make this transparent for a minute to see how deep we're going to go. How deep will we go? The existing one is a little more than 15. What we say this was an M3? Yeah, it seems to be an M3. Let's see what M3s have got and figure out how deep we need to make that. That is not an M3. Maybe. Yeah, I take it back. That's an M3. But wow, it's really deep too. That might not be, because this is a US thing. That may not be an M3. It feels really good, but that may be an M3.5 or American size. Yeah, it's not an M3. It's sort of matched. Okay. Got 3.5s, which are technically not 3.5s. They're, I think, 3/16. Sorry, I don't know, but I think that's the right size. Yeah, 3.5 or whatever that imperial size is. Okay, so it goes 8mm into the device, and my screws are 16mm long or more. I have some 20s, but that seems like excessive. So let's use 16. My washers definitely won't fit, but it looks like I've got some small washers that might too. If I had to use those. How big are these? Yeah, my small washer is a little over 7, so those won't fit anyways, but that's fine. So let's assume we're using a 16. Outside diameter needs to be closer to 3.5. Size is 6. It needs to go 8 in, so from the very, very back here, it needs to be 8mm in. So first, let's bring it all the way to the back edge, and that is 27. So it needs to be, because I have one extra one, so it's really 26, but let's put that right there. So that's 26. Now we need 8. So let's take that to 18. And pull that back out one more so we can grab it. Okay. That should do that. That looks decent on that side. Problem is that this is 3 millimeters. Oops. This. Okay. Let's do this again. The problem is that's too short. Okay, there. That is 3 millimeters in diameter. But my screw is 3.5, and that's a problem. That's 3.4. About 2/10, no, not 2/10, 3.4. Yeah, about 2/10 spacing would be is like the margin of error in a hole like this for an FDM printer. So I need it to move freely as well, so I put another 2/10 on top of that, which will be just under 4. That's an extra 0.5 millimeter, sorry. And we need it to be 3.4. So it really needs to be 3.8 millimeters. And actually we could do that. It's probably cutting it a little close for an FDM printer, but and 4 millimeters isn't really actually that bad. Let's just do 4. It's not going to make any difference. The screw will still fit, even if it's the right size screw, and it's okay if it's a little sloppy. So let's make this 3.5. We're going to add it half to each side. Let's make this 4 and drop it down to half. There we go. That's back in the middle. So we've got our through hole, we've got our countersink, and we've got all those. Let's put this back to solid. Subtract these out. Oops. First this one and this one. Hello hole. There we go. That should take care of that. Looks good, looks good. Something still, I mean, it's not wrong, but it just looks weird. Like it's not in quite the right place. I don't know what it is. But let me double check a few things because it's worrisome. 7 millimeters from the edge. It's slightly off center at the top, but not that much. Yeah, see, that's 10 before the chamfers. That is this 10? Let's double check. Can't check that way. Let's use measuring block. Doink. How big are you? You're 10, exactly. Well, let's make it 7, because that's where the center needs to be. Did I do something dumb? Probably. Pretty good at that. And boop. Okay, that is. That is something. Why is that not? Why is that not 10? That's exactly 7. Why is that? Why is that there? Bevel. When I put that wedge on the outside, more angly words. I put that wedge on the outside, and put it together to make it 10 at the top and 13 at the bottom. Definitely 13 still at the bottom, that's correct. It's actually 12.7 because the bevel cuts a bit of that off, so that would make sense, I guess. That is 13, right where it's supposed to be. Well, let's measure in from this side to see if that's any different. From that side, it should be 6. Is there a bevel on this side that I'm not accounting for? Maybe. Ooh, is there? Let's get the square out. No. Well, maybe the tiniest amount. It's hard to measure with it being so small. No, there's no bevel on that side. And so that pretty much has to be 6 to be right in the middle. Now, that's 6. That's 13. That's 7. It's 1 millimeter off. So what is it about that hole that looks so weird? Is it just because it's half a millimeter off? Is it because that's rounded, maybe? Let's look from the outside edge. That inner hole is 7.4, and it is 1.7 from the edge. Let's look again. Okay, because that is a 7 millimeter hole instead of, I got 7.5 millimeter hole, and I've got an 8 millimeter hole. A 7.5 is 1.8 millimeters to the edge. Split the difference, 0.25, 1.8 minus 0.25 equals 1.5. And that's why it looks weird, because that should only be 1.5 millimeters. And it is more like, well, yeah, at least 2.5. That's 1 millimeter off. There's no way that that goes crooked into there. Well, let's measure to the center of both sides off of this flat edge. Let's see what we get. That hole is centered really close to, wow, a little more than 5 from that side. On the back where the screw comes out, no way, that can't be at an angle. Would they do that? I mean, they kind of have to, maybe? Is it? I would be somewhat shocked. think so. It is. Wow. I guess that makes sense. It would have to be. That hole is crooked. Let's test this out. I'm just in shock. Ugh. Does it really? Is the oh. Interesting. That may be the case. I did not even suspect that. I need a longer straight edge. Well, I know it's a very small angle, but still. I see it now. There is just, maybe I'm just making this up. It's really hard to tell, but there's the tiniest of angles in there. Okay. Wow. Isn't that fun? What did they do on these? Did they make them crooked? '3D viewer, give me, there we go. Nope. This one. Is that hole crooked too? I can't look inside, unfortunately, but I can't get the angles just right. But it appears that it is. Possibly. Yeah, maybe. All right. Well, now we know. That's not so bad, though. It's a little bad because I can't pivot from a single point back here. But I don't really need to, do I? Let me see. I mean, I made that hole a little bigger, and my target is to put it right in the center of that box. So I got a little wiggle room. Here I'm gonna do it by hand. Let's see. We'll do a little couple degrees to bring it on center. Maybe too far. Yeah, that's what I suspected. Just put it back about half that, and then we will slide it over. Maybe not that much. Let's put it at -0.2 just to see how far. Nope, that's not the right one. 0.8. Wow, my number fingers not doing great. Well, that's kind of centered. What's this side look like? No. -0.1. Yeah. -0.1. -0.2. -0.3. Looks good to me. All right, let's look at the other side. Centered-ish. Okay, that was only like 2 or 3 degrees. But I think that's enough to make that. Let's get rid of our measurement block now. All right, I'm good with that. Let's get the last couple of features on the bottom here. So the next part is, we just finished that. The next part's here. I see the problem. My light's off. We need this little hole. Well, we need the threaded hole, and then we need that recessed hole right there. And then we should be able to finish. Okay. And that's kind of important where it is located. Where's the important surface? The important surface is this one, because this is where the corner of the piece of equipment it sits in here, and that's where it screws into. This is the mating surface for the other device that would attach to this. So we should measure it. The hole here needs to be measured from this surface to the center of this hole, or at least the edge of that hole. Let's look. That hole is 7.5 wide. We can make that 8, I'm sure, without any issues. The pin on the other side is 7.4. Yeah, let's make it 8. And that needs to be from that surface. I can extend that to here. Looks like it's about 8.5 to the center. Let's try a better way. There must be a better way to. Yep. A different square. Let's get a big square. There we go. Nope, it's 7. Okay. 7 millimeters in to the center, 8 millimeters circle. Yep. Where did that go? Three millimeters deep. There we go. And now it's the other way is 15 millimeters from the back edge. Okay. Right there. And yeah, it looks right. Now let's put the threaded hole. This thread is maybe an M5, but that outer dimensions are 5. The inner looks like about 4. So let's make a 4mm hole. Just move that down 1. Right. Now we need to, how far up is that from our reference edge? 30mm up. Let's move it up 30. Is that a line? Yes, it is. That's actually a nice correlation. Okay. From the edge, our other reference edge, it is 14. 1, 2, 3, 4, 5, 12, 13, 14. There we go. It's very tall, but that's okay. And I think that's it. Let's pick everything and put it all together. So great. Yes, it does. That side looks good. That side looks correct. That side looks right. Yep. All right, there we go. That is one piece done. Let's see if the other side is just a mirror, because that would make that nice and easy. Probably it's just a mirror. Yep. Yeah, okay. Let's copy this piece. And start a new one. Oops, that was just copy. HP foot. But this one will be the other side, which is 50208938. Top left and mirror left. Three, 8, 3, 8. There we go. Yep. There we go. 2 done. Now the other one is almost exactly the same, but in place of this hole we have a pin, and in place of this hole we have, well, this is a captured screw, but we can not do, I mean we could sort of, but I'm not going to. We're gonna use a different screw and just screw them together if we want to. Okay, so yeah, Let's make another. New design. And if we start from that piece, is that right? Let's copy this. Yep, it's that one. But this will be the bottom right. Part number is 502089337. Let's copy this, paste it here. Let's start with the easy part, the pin. We will take this, and it needs to be probably less than 2, because that was a 3mm hole. Was it 3? No, 2. Make it solid. Bring it down, make it 2. We need to keep it in the same place, but make it a 7mm pin, which means, hang on just a second. Right now it's an 8. We need to take half off each side. So we'll make that 7.5 and 7.5 and 7 and 7. So now it's in the same place. And it's a pin because we made it solid and moved it around a little bit. Now this hole, if we want to use the same size screw, which would be nice, this uses a very long, I don't know, is that an M5? Probably M5-ish. I'm sure it's not M5 because it's Imperial, but I don't have any M5 jack screws, but I can just use pretty much any screw I got. Fine thread. Woo, that's not an M5. Is that an M6? Yeah. My M5 box has M6 in it. My M6 is a finer, my M5 is just a fine thread is all. Okay, I think what I'm going to do, because that, it's a matching piece. It needs to be that same screw. Yeah. Okay. Well, that's fun. I'm sure I've got it somewhere. But not inside. So my machine screws are outside. Let's just pretend like I will have that screw. The hole goes all the way through, so it doesn't really matter, honestly. I could just make a 5mm hole and call it good. And I think that's what I will do. Same deal. We just changed this hole from 4 to 5. And done. Done. There we go. That is it. I mean, the real thing has this jack screw on a spring that's captured and can wiggle around and do all kinds of things, but I think we're just going to use possibly a bigger screw. I mean, it could be this one because the other ones have it. I don't need it to match exactly, so I could replace it with a metric one, since all of these could be metric if we wanted them to, I suppose. Yeah. Or if I have this one on the other device, like for somebody else, we'll just use that. So anyways, good. Let's copy this one, create a new, oh no, I didn't mean to do that. Well, I guess that's fine too. Let's create a new one. Paste it on there, mirror it. If that last one was top left, bottom right, this is the bottom left then. Rear, bottom left. And that's this one. 50208939. Yup. Let's fix the naming of that one. And then we can export these. See, rear top right, rear bottom left, rear bottom, whoa, yeah, rear top right, rear top left, rear bottom left, rear bottom right. Yeah, it's turned around the other way, that's why. Yeah, all the rest are turned. Let's see if I can keep it. Nope. Okay. I know why. Well, it doesn't matter. Okay. They're all labeled, named correctly. Now we need to download them as an STL, because that's what my printer uses. And lots of downloads. Where's my HP stuff? Well, got everything else sorted, just not these apparently. Rear top right, rear bottom left. Download STL. That one was there. Close, and we'll get this one download there. Okay. All right. So I need to. Oh, it's almost time to go. One last thing to do is load them up into the slicer for the printer. I use Prusa slicer. Let me change to there. switch to this view. There's my Prusa slicer. Let me grab the files and dump them in there. There they are. Lay them out. Of course, they all seem to have some face problems somewhere. Something overlapped in a weird way, probably. But fix those. Yeah, I would probably use PETG, except I am out of PETG. So let's switch to Cement PLA. Infill needs, only this part needs to be strong. The rest of it, I don't think it needs to be. So let's just stick with the pretty normal 30%. I am doing pretty rough layer heights, 0.4, because I don't need it to be anything stronger than that. There's no, the only overhangs would be right here, and it can easily deal with that. These are only a little bit of stick out, so it's going to look a little lumpy when it prints. Possibly like this one might droop a bit, but it's going to be fine. I could bevel that so that if I could go on like a 45-degree angle, and that way I wouldn't have any problems, but it's so small that I don't think it's going to be an issue, but I'll print them, and if it is an issue, we'll take it back. Oh, I just realized that this surface to this surface is the important one. I wonder if that's going to be an issue. Probably doesn't matter. Hour and 20 minutes. No, because that's the other side. That doesn't matter. So this face is the important one. That thickness doesn't matter. Yep. Okay. This screw height to this, we made sure that was right. That's important. This is a little thicker. Should be fine. Should be. All right. Well, that's it. All right. The last thing for me to do is throw it on the 3D printer, and we'll, maybe the next stream I will share that, and we'll see how it goes. Or follow me on Mastodon, and we'll see if it how that looks. I'll post some pictures over there later. So again, I know long stream. Well, I don't know, we did almost 2 hours of modeling here for relatively simple parts. But I'll see you next time. Bye.